Chapter 1, Section 4 is about patterns and functions. Lots of vocabulary for this section. The word function is a relationship that assigns exactly one output to each input. We'll talk a lot more about functions later in this course. A function rule is an equation that describes a function. We'll be doing a lot of that today. Dependent variable and independent variable. You can think of these just like you do in science class. Your independent variable is the one that's manipulated. It's the one that I change. The dependent variable changes because of that, or as a result of the independent variable. And then the words domain and range. The domain is the possible values for an independent variable, where the range is the possible values for the dependent variables. And remember, a lot of times in math, your independent variable is your x value, your dependent variable is the y. Like I'm going to plug something in for x and get out something for y. So your domain you can think of is the set of all your x's, and your range is the set of all your y's. And then your objectives for this section are to write a function rule and to understand a relationship as a function. So let's write a function rule. I have two tables here. You need to define the variables first and write a function rule. So define your variables. The first one is talking about the number of loads of laundry and then how much it costs. So the two things we don't know, let's give them letters. L for laundry, C for cost. And now you kind of have to decide which one's your independent variable, which one's your dependent variable. So if you think about this situation, the number of loads of laundry is the thing I change. That's what I am going to plug in, and then as a result of that, my cost is going to be affected. So this is my independent variable, and this is my dependent variable. And we always write things in terms of the independent variable, which means that our cost is going to equal something. So then we have to stop and think about how these two are related. And it gives us an easy change here because this is just going up by ones. And as each load of laundry goes up, hopefully you notice that the cost goes up by $2.75. So that right there can be our equation. Each load of laundry is going to cost $2.75. So my cost is $2.75 times the number of loads of laundry I do. And then with this equation, if I gave you any number of loads of laundry, like let's say I washed 10 loads of laundry, you should be able to tell me that it's going to cost me $27.50. Now the next one is about the number of houses I can build versus how many toothpicks I have. Think of it as like a house like this that used up 1, 2, 3, 4, 5, 6 toothpicks. And then I'm going to build another one on top of it, like right next to it, and that only requires 11 toothpicks. And we could keep going and keep drawing, but we kind of get the idea. So now we got to define our variables. Number of houses, let's use H for house, and the number of toothpicks I need. So then you have to figure out what this relationship is. So again, these go up by ones, and this goes up by 5, this goes up by 5, this goes up by 5. So we have a steady rate of change here. But the thing that makes this different is one house doesn't use exactly 5 of them. So my equation can't be that the number of toothpicks equals 5 houses, or 5 times H, because that doesn't work. It doesn't work for this one right here, or this one right here, or this one right here. What this would give me is a 5 here instead, and then a 10 here, and then a 15, and then a 20. Hopefully you notice I need to add 1 to each of those values to get what we need. So we can write that in our equation. The total number of toothpicks I need is 5 times however many houses I want to build, plus 1 more. And again, this could work for any of them. If we added 5 here, this would give me 26 for 5 houses. And if you plug that in here, 5 times 5 gives me 25, plus 1 more would equal that 26, the number of toothpicks that I need. Alright, part 2. Relationships in a function. Identify the independent and dependent variables in the following situations. So my first situation is the cooking time for a turkey is about 20 minutes per pound. So what's the independent variable? What is the thing that is going to change? If you think about this situation, it's the number of pounds of turkey. And then based on my number of pounds, it's going to tell me how long I have to cook it. So cooking time. And think about how you would figure this out. You would say, well, if my turkey was 10 pounds, I'd have to cook it for 20 minutes. So the thing that you gave the answer to was the number of pounds. That is your independent variable. So now the next situation. The cost of a cell phone data plan is $10 for every single gigabyte. So how much would it cost if I use 10 gigabytes? The how much would it cost is dependent on the number of gigabytes. And we'll do some more examples about these in class if it's not making complete sense. But now, with these relationships, let's find a reasonable domain and range for the situations. Remember, domain is your x values, or your independent variables. And your range is your y values, or your dependent variables. So we need to figure out again which ones are independent variable and which ones are dependent variable before we can decide what values are reasonable. So if Monica earns $7 an hour babysitting after school, and she can work no more than 10 hours a week. So her independent variable, the thing that she is going to change, is the number of hours. Now let's think about possible values for this. She could work 0. She could work Now let's think about possible values. She could work 0 hours. She could work anywhere in between like 0 and 1 hour. And it says up to 10 hours. So my independent variable is anywhere between 0 and 10 hours. That is my reasonable domain. And now my dependent variable. What is dependent on the number of hours she works? Well, it's the amount of money. And then again, we got to come up with a reasonable range. So for my range, she again could make $0 all the way up to however much she makes with 10 hours of work. And since she earns $7 an hour, that is $70. So a reasonable range is somewhere between 0 and 70. So now, second problem, we're going to do the same thing. Tara's car gets 25 miles per gallon. She has between 10 and 13 gallons of gas in her car. So before we can do anything else, let's figure out our independent variables and our dependent variables. So what is independent? If her car gets 25 miles per gallon, the distance she can travel is dependent on how many gallons of gas she has in her car. So the independent variable is gallons of gas, and then the dependent variable can be miles traveled. If she has anywhere between 10 and 13 gallons of gas in her car, remember we just decided that that was our independent variable. So anywhere between 10 and 13 is a reasonable domain. And then with that, how many miles can she travel? Well, if she only has 10 gallons of gas in her car, then she can travel 250 miles up to 13 gallons. And 13 times 25 will give you 325 miles. So with that amount of gas in her car, she can only go 250 to 325 miles. So, can you do this? Can you write a function rule if I give you the number of hours and the cost of a bike rental in a table? And can you understand relationships as a function? So you're going to do the same thing that we just did. Find a reasonable domain and range.